Assalamualaikum and very good morning, ladies and gentlemen. Today we are going to learn about appraisal stage of the life of oil and gas fields. Oil and gas field appraisal is undertaken to determine the size and characteristic of a petroleum discovery. Appraisal is important because it provides cost-effective information that will be used for subsequent decision, which is development stage. Why we proceed with appraisal? More information about the reservoir is necessary, hence the discovery appraisal is needed. General principle for appraisal is to estimate the minimum size of the petroleum accumulation needed for commercial development. Appraisal begins with a series of more detailed investigation and studies on the area of interest. Detailed seismic survey, called production seismic, should be made to assist in selecting drilling locations. Appraisal typically involves drilling more wells, which have a comprehensive data acquisition program. To simulate the reservoir fluid flow behavior and optimize the field development scenarios, i.e. number of wells, type and location of wells, level of field production, appraisal wells are drilled to improve the field description through data acquisition. Field appraisal phase aims to reduce the range of uncertainty in the volumes of hydrocarbon in place, define the size and configuration of the reservoir, collect data for the prediction of the performance of the reservoir during the forecasted production profile. If we look at appraisal plan, work program and budget, we will have development appraisal, then develop work program, estimate data requirements, prepare schedule, estimate resources, and get the budget approval. For data gathering, we have to assimilate or integrate with exploration data, then acquire process seismic data, gather all reservoir data, acquire process well log data. We have to estimate data uncertainty and organize asset data. From there, we develop asset model and develop appraisal scenario. Next step is to prepare well design and drilling plan, followed by actual drill of wells. From the well result, we need to perform resource assurance, then evaluate economic viability of the asset or the field. The next step is to optimize and rank portfolio. We then have to propose conceptual development plan, and we have to prepare regulatory reports. Finally, hand over appraisal result to development team. As I mentioned before, the major activity in appraisal stage is appraisal drilling. Appraisal drilling is undertaken to establish quality, quantity, and other characteristics of oil or gas in a newly discovered field. Appraisal well is drilled to establish the extent and size of a petroleum deposit that has been already discovered by a wildcat well. These are rigs in those days. These earliest rigs were made of wood, as they would be quickly built up. Rigs couldn't be easily moved once they were built. These wooden rigs also proved dangerous during blowouts, as they could catch fire if sparked. Through this period, drilling rigs mostly use a percussive technique that works by repeatedly slamming a cable tool into the ground. In 1901, The wood construction rigs were powered by steam engines were introduced. Steam engine was required to pull and drill supply steam to it and to haul water. And the first blowout preventer, BOP, was invented in 1924. Since then, blowouts or gushes became a thing of the past. We will learn more about BOP in the next module. Rig nowadays. Advancement in both hardware and software contributed to a modern renaissance in drilling technology. One rig is now able to drill multiple wellheads instead of having several rigs on a pad. There is no longer a need for tear and down and set up each time a rig must be moved. Modern rigs able to drill in multiple directions underneath the ground. To overcome the challenges of offshore drilling, oil companies invested billions to develop offshore drilling rigs and offshore oil platforms. They are built to withstand the elements and equipped to go into depth. The offshore drilling units can be jackup type or rig that sits on a barge and keeps the rig safe from the water by extending its legs. There are semi-submersibles that operate atop of a submerged pontoon. There are also drill ships. These look like ordinary sea vessels but with a hole on their hull where the drill is piloted. For onshore rig, the anatomy of modern onshore drilling rig remain consistent. They have a power steam, a mechanical system, and rotating equipment that does the drilling. Modern rig setups add newer technologies for efficiency, safety, and convenience. Water depth dictates offshore rig type. As you can see in the picture, a swarm barge is a vessel used for offshore drilling in very shallow water. Tender-assisted rigs are an existing type of development drilling over or plug and abandon rig. Tender-assisted drilling rig is stationed next to the platform and its drilling package is lifted onto the platform. Jackup rigs are floating drilling rigs with 3 or 4 movable legs, which can elevate when rig relocates from one location to another. Semi-submersible rigs make stable platforms for drilling for offshore oil and gas. They can be towed into position by a tugboat and anchored or moved by and kept in position by their own azimuth thrusters with dynamic position. The rigs are used to drill wells in water depth up to 9,500 feet or 2,900 meters. A fixed platform is a type of offshore platform used for the extraction of petroleum, and drill ships are special purpose ships that can drill the ocean beds at deep seas. Appraisal drilling is a very complicated activity, and the details of operations depend largely on the unique geological characteristics of the particular case in hand. Because of the complexity and uniqueness of the geological conditions in most oil fields, the planning of field appraisal is to a considerable extent based on subjective judgment. The process of drilling appraisal well is as follows. First, boring. A drill bit and pipe are used to create a hole vertically into the ground. Circulation. Drilling mud is circulated into the hole and back to the surface for various functions, including the removal of rock cuttings from the hole and the maintenance of working temperature and pressures. Casings. Once the hole is at the desired depth, the well requires a cement casing to prevent collapse. Completion. After a well has been cased, it needs to be ready for testing. Small holes called perforations are made in the portion of casing which pass through the production zone to provide a path for the oil or gas to flow. Plugging and abandoning and temporary well suspension, i.e. mothballing the well for future use as development wells. Sidewall sampling. Sidewall samples are developed to obtain core samples after a well has been drilled and logged. Taken by a device lowered into the well by wire line to a desired depth and shot into the wall of the well by means of an explosion. Samples of the formation are then collected in a cylinder. Complementing logging and wireline formation testing, sidewall coring is a faster, cost-effective alternative to conventional cores and avoids the ambiguity introduced by the depth uncertainty of drill cuttings. Sidewall sampling data are particularly valuable as basis of calibrating electrical log data, sidewall core analysis. Data show the actual presence or absence of hydrocarbon content and indicate the type of production. Sidewall core analysis in formation evaluation. Sidewall core data usually establish the presence or absence of hydrocarbon content and indicate the probable type of construction. Measured permeability and porosity values indicate productive capacity. The data show gas, oil, and water oil contacts. Sidewall sample data are particularly valuable as a basis for calibrating electrical log data. Sidewall coring is applicable in cases where many possibly productive zones may be encountered or data indicate that a pay zone may have been drilled through. The sidewall sampling provides a qualitative information which can be obtained in no other way after the formation has been penetrated. Well logging. Measurement of certain properties of the penetrated formations by running logging tools in the well. Information are simultaneously recorded on a chart at the surface. Time and amount of fluid content can be estimated. Characteristic of the rock can be determined. Production potential of a reservoir can be evaluated. Well logs are used while drilling to determine a well's suitability and to record any event such as any problem occurs along what kind of formations are being true. The advantages of logging while drilling include target zone detections and proper drilling orientation. An overview of well logging. Logging procedure consists of lowering a logging tool on the end of a wire line into the oil well to measure the rock and fluid properties of the formation. An interpretation of these measurements is made to locate and quantify potential depth zones containing petroleum. Logging tools measure the electrical, acoustic, radioactive, electromagnetic, and other properties of the rocks and then their contained fluids. Logging is performed at various intervals during the drilling of the well. The data are recorded to a printed record, well log, that can be transmitted digitally to other locations. Measuring and recording of this property provide a good deal of information about the rocks. Detector transmit its measurements via conducting cable at the surface where computers record them. Experts analyze the resulting recording the log. Logging tools to measure rock properties. By using well-logged data, the user may be able to calculate, first, shale volume. An equation was developed for evaluating the volume of shale using standard porosity logs such as neutron density and acoustic logs. Second, water saturation. Resistivity logs are used to obtain water saturations. After obtaining water saturation, both oil and gas saturation can be calculated. Third, porosity. Porosity can be determined using density, neutron, and sonic or acoustic logs. Fourth, permeability. To estimate permeability, we can use values of porosity, pore size distribution, and water saturation from logging data and establish correlations. Number 5, elasticity. Elasticity and reflectivity coefficient are also derived from the logs and calculated using the formulation accordingly. Well log is one of the most fundamental methods for reservoir characteristic in oil and gas industry. It is an essential method to acquire condition below the surface. This method is very useful to detect hydrocarbon zone and calculate the hydrocarbon volume. Logging tools to measure rock properties. Logging tools are inserted into the well to measure the electrical, acoustic, radioactive, and electromagnetic properties of the subsurface formations. Sometimes the logging tools are incorporated into the drilling tool, and sometimes the drilling tools are lowered into the well at regular intervals to collect data. As shown in the picture, the logging tools are small in diameter and are run through tubing for evaluation of the well. Electrical log. A record of certain electrical characteristics such as resistivity and conductivity of formations traversed by the borehole. Electrical logging consists of lowering a device used to measure the electrical resistance of the rock layers in the downhole portion of the well. This is achieved by running an electric current through the rock formation and measuring electrical resistance that the current encounters along its way. It will identify the formations, determine the nature and amount of fluids they contain, and estimate their depth. Electrical logs are perhaps the most important tools available to petrophysicists. This is because they provide a method for calculating the water saturation upon which calculation oil in place are based. The electrical log has been used extensively in qualitative way to provide some indication of reservoir content. Flowchart to analyze well logs that must be done to characterize an oil and gas reservoir. Flowchart here indicates steps to analyze well logs that must be done to characterize an oil and gas reservoir. We should follow this step in order to acquire the correct result. Firstly, data loading and preparation. Interpret the lithology, followed by calculation of the shale volume. From there, we can calculate the porosity. From the calculation of the porosity, we can have three calculations, which are calculation the water saturation, calculate the elastic properties, and calculate the permeability. From these three calculations, we can calculate the reflectivity coefficient. From there, we can plot the data and make some cross plots. And then we interpret the data and complete the well logging interpretation. log interpretation. The lithology can be interpreted by using several logs. There are gamma ray, spontaneous potential, resistivity, and density log. A formation with high gamma ray reading indicates there is shelly or shale. Low gamma reading indicates a clean formation, sand or carbonate. If lithology interpretation is wrong, the other steps such as porosity and water saturation calculation will be a total mess. As we discussed earlier, lithology is a description of rocks in outcrop based on their characteristics such as color, mineral composition, and grain size. Lithology is significant mainly in connection with permeability. In the petroleum industry, lithology or mud logging will help predict and calculate resource and a good area. With lithologic knowledge, we can deduce things like porosity, water saturation, permeability, and other physical properties of rocks. Radioactive log. Sealed radioactive sources are routinely used in formation evaluation. Measurement of formation density is made using Ca-137 salts. High readings indicate shale and low readings indicate non-shale formations such as sandstone, limestone, and reservoir. Shales are characterized by very low porosity and very low permeability. Radioactive log is a log of borehole obtained through the use of gamma, neutron, or other radioactive logging methods. Radioactive logging curves will provide the information on important quantities such as the porosity and the liquid saturation of the formation. The sampling of radioactive curves is known to penetrate radially much deeper into the formation than other methods such as core, side swab sample, much larger sample than other methods. The radioactivity curve sampling, therefore, is superior, especially for those formations exhibiting an extremely heterogeneous porosity distribution. Here, this shows a clean sand with good porosity and resistivity. Acoustic or sonic log. Determine the porosity of a formation by measuring the time travel for a sound impulse through a given depth of rock formation. Speed or velocity of the impulse through the rock depends on the composition of the rocks and its fluids content. By interpreting sound travel times, the porosity of a rock, which is the important factor of potential reservoir, can be determined. Acoustic logs have become a widely used porosity tool in formation evaluation. Significant benefits in formation evaluation can be gained by a more complete use of acoustic wave train generated in the borehole by an acoustic logging tool. On the whole, sonic log can be used to calculate porosity, confining stress, pore pressure of a formation, if the seismic velocity of the rock matrix and pore fluid are known, which is very useful for hydrocarbon exploration. Ladies and gentlemen, this will end Module 1 of Basic in E&P Training. I really hope you have benefited from the session that I have shared with all of you. Now you have learned an overview of petroleum industry, oil and gas field life cycle, full spectrum of basic exploration activities, and we have touched on appraisal, especially on appraisal drilling and well logging. In our next module, which is Module 2, we will continue on appraisal subject where we're going to touch on reservoir evaluation and drilling operations. In Module 2, we're going to learn about one of the most important subjects in the E&P training, which is Field Development Plan, or FDP. Until we meet again in the next module, thank you everyone and have a nice day.